This code. No doubts. Fine. Not done anything complex. Yeah. Once you guys are done going through Workday, right? Just react, like put a thumbs up or something. Okay, see two thumbs, three thumbs up. Nice. Nice. So I hope everybody is logged in now. So we'll start with the session. So here you're going to be again working with ESP32. That's why we're choosing Workday again. You guys can go to this top left, top right icon and press My Project. And we're building a new project from scratch, right? And click the first board which you see, ESP32. And go for the beginner templates, Arduino template. So yeah, here is our ESP32. And to this we are adding an OLED, right? So I'll go search for OLED here. Go choose the first display which you see, right? This display. Okay, so yeah, with that done, we'll start wiring this. So here in Workday, the color coordination is by default done. Like for the 5 volt and ground, it's already done. If you want, you can give different colors for SCL and SDA. So first we'll connect the ground. So this is the ground pin, the top right pin, and we'll just put it on the ground here. Just click this, drag, and click the other end to the pin where you want to connect it to. So we'll do the same for VCC. So the 5 volt, which is the left, the last one which you see, press it and drag it to this VCC port over here. Okay, and then we'll connect the SCL and SDA. In the ESP32, by default, the SCL pin is the pin number 22 mentioned here. So pin number ESP22 is the pin which you'll have to connect to SCL. So be careful about these pins, like you shouldn't wire it to anything else. So SCL to pin 22 and SDA to pin 21. So basically this is all the wiring which you're going to be requiring for this. So the setup is done. If you guys have any doubts, you guys can put it in the Q&A. I'll check that. No doubts so far. Okay, pretty good. Are you guys done with the basic wiring? Can we start with the code? If yes, then just put a thumbs up. Only one person has done. Okay, I'll give you guys some more time. So SCL is connected to pin number 22 and SDA to pin number 21, ground to ground, and VCC to the 5 volt. This is all we have done. So hope you guys have done this part. So we'll start with the coding now. So basically you will need certain libraries for this. And the first one being wire.h. So wire.h is again used for ICC connection, right? So that's what we're going to be using. Capital W, guys, be careful about that. So that's the first library we are going to be using, wire.h. And the second library we are going to be using is Adafruit library, which I already told you guys. So this is the library which you're using for displaying stuff. And this is this library, like Adafruit SSD1306.h, because this is actually 1306. SSD1306 is the name of this display. So these are the two basic libraries we are importing, and we'll given the basic parameters now. like the screen width, height, and the address, reset pin, all of that. So these are just constants. You guys need not worry about this. So the screen has a width of 128 and a height of 64 pixels. So that's what we're going to do. So we'll declare it as an int data type. If you want, you guys can use constant also. That doesn't matter. So screen width equals 128 int screen. I'll put caps. Height equals 64. So width and height done. There is an internal reset pin which we'll have to define. You need not worry about this at all. These are just constants you're defining at the beginning. And there is an address. Like any display, this also has an address which is 0x3 capital C. Okay, and these are all the basic stuff we'll have to define. And then we will initiate the display right now. So the function is add a fruit SSD1306 the display, and it takes in some basic parameters like the screen width, height, reset, and address. These are that's why we have defined it before. So if you don't want to give it as some variable, you can directly put stuff here, but just for good programming practice we prefer declaring variables there. Screen width, height, and wire. Like this is that I2C thing which we're using, right? So we're using that reset. So with this, the screen gets initialized. So we'll go to the void setup now. Void setup contains the stuff which I run only one time during the program. So I'll just use a serial monitor so that I can print stuff if required. This is kind of like just for testing purposes, but we'll just use it. And baud rate will give the traditional one, 9600. And so we'll have to check if it is connected, the ESP32, and the display, if it is connected, it's well and good. Otherwise, we don't want it to go into the void loop, right? So this is kind of just checking if we have done our connections properly. So if display is not connected, so the function is display dot begin of, and it takes in certain parameters which is called as SSD1306. Wait. BCC, comma, address. So you guys may be wondering what this switch, what this variable is. So this is an inbuilt variable which will power the display. That's it. And address we have already defined before. It is the physical address of that screen. And if this exclamatory tells that this is not true. So if the display is not connected, then we'll just print it in the serial monitor. Print ln of display not connected, that semicolon, and we'll just not break the loop and keep it. Like you might be wondering what this for semicolon stands for. This just does that we are creating an infinite loop which has no purpose. It just doesn't exit this loop. That's it. So with that done, the void setup part is completed. So we'll go to the void loop part. This is the part which is going to be run on loop. So for the display, you'll have to initialize the text color, text size, and where you want to put the monitor and what you want to display. All of that we are going to be defining here. So this display actually supports only black and white colors. And black color, if you write also, you're not going to be able to see anything. So we'll stick with white. So first I'll set the color. No, size. I mean display dot set text size. So first I'll just give you a size of 1, and you guys can run it multiple times with changing each parameter. You'll see the difference. I'll be showing you just two different sizes, and then we'll set the color, set text color, and we'll put that as white. And we'll set the display at the cursor at 0, 0, which is this point, the left uppermost point here. So that's 0, 0. display dot set cursor at 0, 0. So this is like the basic things which we have been always doing, right? A regular Cartesian coordinates, that's it. And then we're gonna display hello world. Okay, so we'll write display dot println. So you're using println because you want that to be printed in one line. And the next thing whatever you're typing will get printed in the new line. That's the thing. Hello world. And then there is this function called display dot display off. So what does this do is that if there is something in the memory buffer which still hasn't come to the screen, it will push it to the screen. That's all this is supposed to do. And we'll delay it for say 2000 milliseconds or 2 seconds basically. And then we'll clear the display. Display dot clear display. What have we done so far? We have set text size to 1, text color to white. We have put the cursor at this top leftmost corner and we are printing hello world. We are displaying it. We are delaying it for 2000 milliseconds and we are clearing it. So just to show you guys the difference, right? Like the size difference, which is kind of possible. I'll just copy this thing and I'll paste it another time so that I'll put the size to 2. I'll put the coordinates somewhere else, say 0, 5, and I'll just print hello. Okay, so this is the basic coding part. We are done with it. So you guys, I'll give you guys 2 more minutes to complete this part. And in the meantime, if you guys have any doubt, put it in the Q&A part. We'll clear it for you guys. No doubt so far. Nice. So you guys are just following this, I presume. If you guys are done, just react, like, thumbs up or something, so that I'll start with the simulation. So I'll just go through the code again so that you guys have time, in case you guys are doing anything, you will have time again. So the basic library which we're including is the I2C library, wire.h, and Adafruit SSD1306, which is this display. And we are initializing the screen width, height, reset, and address so that we can initialize it here. Adafruit SSD. And all of these are capital actually, SSD. Sorry about that, just correct that part. Screen width, screen height, unwire and reset. And we'll go to the void setup and we're initializing the serial monitor. And if it is not getting, if the display is not connected, then it will print display not connected and it will forever be in the loop. It won't come to this part, the void loop. Otherwise, you'll get unnecessary errors, right? So that's what this part is actually for. And then we have come to the void loop. We're setting text size, color, position of the cursor, and the message which is to be printed. We are displaying it for 2 seconds or 2000 milliseconds, and we're clearing the display and printing another message. So I've actually put this part so that you guys will see the void loop running. That's all. If you guys want, you can put only the first part. That's fine. So we'll start the simulation of this. So in the beginning, you're bound to get errors telling that, these two libraries are not there. You can install it. So you can see, right? Adafruit SSD1306 library. Just click install. So in the library manager, it will show you this library being installed. So you guys can go back to sketch.ino again and start the simulation once more. And if there are no errors, then you will see the display, like, stuff being printed on the display. What is for semicolon, semicolon do? It's just a basic loop. Like it's a never ending loop which does nothing else. That's the only thing. Do we have to remember the code for real purposes? I think you guys can always refer to this. But this code is necessary every time you're using an OLED display. What is the use of EMT5 for loop? Oh, it's just that it doesn't go to the void loop, so you guys can avoid whatever errors, Otherwise, it's going to throw errors like the display isn't initialized or something like that. Is there any advantage of using ESP32 over Arduino for OLED? I don't think there is any difference, but since we already introduced you guys to Vokvi and ESP32, and ESP32, as I said, has slightly greater advantages as compared to Arduino, we're doing that. That's it. So you guys can see it is running, like the text difference you can see, and the cursor position also, like hello world is printed in the first part, and see it's come down. So that's basically how it is done, because it's x comma y, right? And the y coordinate we have changed here to 5. So pay fifth pixel, this is going to be printed. This is basically how this works. Why do we need infinite loop in setup part? I hope I've cleared that doubt. It says build failed. So, oh, it's commented on. Yeah, you have to try compiling it. Somewhere the connections you might have not done properly. That's the only thing. Otherwise, it should be working properly. So I'll just wait here for a minute so that, in case you guys have any other doubts, you can comment that. And we'll resume with the theory part again after this. Unexpected. Have you missed some semicolon or something somewhere? That's what it is saying. You've missed a semicolon somewhere, Isha. Just correct that and I think your code should be good to go. So this code is kind of important. Just save it. Reset is like, it's some internal classification. That's it. Like, certain initializations you'll have to do, right? So this is reset equals -1 is one of those. So make sure you guys have gotten this properly, because with only this you'll be able to proceed further. Like this is kind of the basic foundation for your game building. So make sure you guys have properly simulated this and you guys are getting no errors. Because we'll, and save this, because this is what we're going to be building the game with. We'll just add a few push buttons and change a bit of the code and you guys should be good to go with the game. Okay, so I think you guys are all done with this part. I'll just rush you guys through some, basic terminologies and then you guys can start with the game. Just a minute, I'll reshare my screen. Hope it is visible. So this is a model simulation which I've put. If you guys want, you guys can refer to this later. So with that, we'll come to something called pull up and pull down resistors. This terminology is kind of important because only then you'll have properly functioning, push buttons or anything in general. So what does a pull up resistor do? By default, what it says is that that device is pulled to a high state. Now, what exactly I mean by this is that let's say there is this push button and this configuration is pull up. So why am I saying that? Is because you see this is connected to the 5 volt, right? That resistor is connected to the 5 volt, and now this button will act as a as pulled up part. What it means is that when I press the button, right, that is when the switch is closed, the input is high, and when the switch is open, that is when I don't press it, it is low. That's basically what it is. Okay, there's something called as pull down resistor, which is the opposite. So by default, it is in a low state. So what do I mean by that? Is that we'll go to the same example, but now this resistor is connected to the ground part. So so what I'm telling is that when the button is pressed, that is when the switch is closed, it is in a low state, and when the switch is high, when the switch is open, it is in a high state. That is when it is not pressed, it is in a high state. Okay, so that's the basic definition of pull up and pull down. So with that, I think we'll go back to that simulation which we had, and we'll add the few push buttons which we need so that you guys can start coding the game. So I'll go back to the project. Like, hope it's visible, my screen. And I'll stop the simulation here. And I'm going to be adding two push buttons, one for moving right and one for moving left. So I'll go here. I'll get the push button and press keyboard. On the keyboard, you can press an R or you can press this key, right, which says rotate. It's gonna rotate it this way. And I'll add another push button. This is for the left and this is for the right. So yeah, so we got two push buttons ready. Now we'll do the wiring part. So we're gonna be having pull down resistors here. So I'll add the resistors. You can keep the default resistors, that's fine. I'll rotate this also, this resistor. I'll connect it here. Yeah, properly connected. One more resistor I'll add. I'll rotate this. Get it here. I'll rotate that push button. I'm sorry, the resistor, and I will put it here. And both these you have to connect to the ground now. So ground. I just move these push buttons a bit down so that it doesn't interfere. If you want, you guys can connect these tools like better, I don't want any wiring issues there, right? So that's the control press and control minus for zooming in and out of this place. So we've connected that to the ground, and then we'll connect it to the 5 volt. So you guys already know about the wiring of a push button. It was discussed in session 1. Just using that only here also. Okay, with that it's done. So you need a pin, for, you'll apply digital ray, right? So for the left button, I'm going to be using pin number 16 here, ESP16. That's the pin. And for the right, I'm going to be using pin number 18. So this is arbitrary, but you'll have to define it in the code. If you guys want, you can use any other number. Like that's all up to you guys. But in the, in the code, you'll have to accordingly modify it. That's it. So basically, our push buttons are now connected. And I'll just add an LED again, which is something you know. And why am I using this LED? I just want to blink it, when the ball hits the paddle or when the game gets over. For all of that, I'll include this. I'll add a push button, I'll add an LED. Again, the wiring of an LED you guys have already done. And again, I'll use a resistor. You need not change the value. You can keep it as it is, 1 kilo ohm. I'll rotate this. And I'll add it there. Looks a bit messy. I'm sorry about that. But yeah, this is how it works. Okay, and then I'll connect this to ground. And again, for blinking the LED also, you'll have to connect it to some pin in the ESP. So I'm using, say, pin number, I think I'll go with pin number 19 here. So yeah, done. So this is all you need for building your game. So what have we done so far? We have wired your OLED screen and we have added two push buttons and an LED. So all these connections you guys already know. So I hope you guys are finding it easy here. If there are any doubts, just put it. Can you please can you please repeat the construction? I got disconnected. Yeah, sure. So it's basically like the OLED you're connecting to VCC and ground, and the SCL goes to pin number 22 and SDA goes to pin number 21. And then you have connected two push buttons. So push button is we kind of using pull down resistors. So we are connecting the resistor to the ground part. That's all we have done here. And we have connected the other end to VCC. And you'll have to, check if the push button is pressed or not. So you're connecting it to 2 points in the ESP32. Can be any 2 points, but you'll have to accordingly define them in the code when you're writing. And then I have added an LED. Oh, the other end I haven't connected. I'm sorry. Wait, I thought I did connect it. My bad, I connected it to the wrong thing. Just a minute. Sorry, it's from this thing to pin number 92. Sorry about that. So hope you guys are done with this part. And with this, I think I'll hand the session to Deepti, who will be explaining you all the coding part. Oh, yeah.
Hi guys, let's get started with the creation of the game. So I'll be teaching you stepwise how we proceed in the game to make that ping pong game. Okay, so let me share my screen. Yeah, is my screen visible? Please give a thumbs up if it's visible. Okay. Um. So let's get started. Now, what is it that we will be needing to make the game? Anybody can guess what is it that we will start with? The first thing that we will need to make a ping pong game. Any guesses? Okay. So we will be first starting with making a ball and a paddle. We will first create a ball and a paddle. That is using some functions that are a part of a library called Adafruit GFX. So let me go here and add another library, which is yeah. So what is this library for? It helps us create different shapes. It helps us create shapes of different sizes. All the graphics related drawing and all that come to use that we need a few functions. We take the help of the functions which are a part of this Adafruit GFX library. So let's proceed and first create a ball and a paddle. For now, I'm just going to clear this part. Hope you all are with me. If you think I'm going fast, please let me know so that I'll slow down. So let me make it as display dot fill circle x1 y1 comma 2 comma white. So what does this mean? So here x1 y1 are the coordinates of the center of the ball, and 2 is going to be the radius of the ball, and white is the color that we have chosen. So when I write display dot fill circle x1 y1 2 comma white, I will be creating a ball that whose center coordinates are x1 y1, radius is 2, and color is white. Now let's make a paddle. Paddle is basically the rectangle that will on which the ball will hit. So display dot fill rectangle x comma y comma 20 comma 4 comma white. So what are the inputs that we are giving to this function? X is the x and y are the position coordinates of the top left corner of the rectangle, and 20 is going to be the length of the rectangle, and 4 is going to be the height of the rectangle, and white will be its color. Okay, so let's now we will write display dot display. So what does display dot display do? If there are any changes that are being made, that those changes will be updated. Okay, so we are now done with the creating of the elements that we need for the game. What is the next step? Next will be to define variables. Now what are the variables that we might need? We need one for the position of the ball, one for the position of the paddle, and one that will that are constant variables, basically the speed coordinates. That is what is going to be the speed of the ball. And there is also one important part of the game, that is going to be score. So score is also a variable that keeps getting updated every time the ball hits the paddle. So let me define a few variables here. First being int x1. Yeah. So x1 is going to be the center of the x coordinate of the center of the ball. So let's say when I start the game, the ball starts from, say, x1 equals 64 and int y1 equals 32. Okay, so this means that at the start of the game, the initial coordinates of the ball will be 64, 32, which is exactly at the center of the OLED screen. Now the next variable that I define will be for the position of the rectangle. So notice that because I'm defining here as x1, y1, because while creating the circle, these are the center coordinate variables that I have used. So for rectangle also I will be doing the same. So I'm going to take an arbitrary value for the start position coordinates of the rectangle, which let's say is 55, x equals 55, and int y equals, that will be, let's say, 60. Why is it? Now there's a reason why x, though it can be anything, because paddle, as Akshaya showed in the slides, the paddle will be moving and on the lower base of the screen. So the x value will keep varying for the paddle, but the y value will remain constant, and that is equal to 60. Why? Because the height of the rectangle, as we have defined, is 4. So hence y ka coordinate will be a constant throughout the game. Okay. So these are the I'll add comments for clarity. Position coordinates of the center of the ball, and these are the top left corner coordinates of the paddle. Okay, now I will define a speed variable. Let's say that is int x speed, that is equal to say 1, int y speed, which is equal to 1. So this is going to be the speed of the ball. Okay, so why have I defined x speed and y speed? I will be eventually adding it to the position coordinates of the ball. Okay, so these represent the vectorial, like if I have to write the speed of the ball, it will be 1 x cap plus 1 y cap. Okay, so now of course the most important part, score. So at the start of the game, score is going to be 0. Okay, hope I'm clear. I hope everybody is going along with me. If I need to slow down, please let me know. Okay, now what is the okay, before starting anything, there is something that I've forgotten to do, and that is to define the pins. Akshaya has connected push buttons and LEDs for me, and I have to define them. So let me do that. So here I will say pin mode. Okay, so this push button is connected to the 16th pin. So I'll write it as 16, comma, and it's going to be input pull down. Why input pull down? Because it is the resistor attached to the push button is connected to the ground. So that's why input pull down. And when I say input pull down, I mean that when the push button is pressed or when the switch is closed, the this goes to high. Okay, the pin goes to high. Okay, what part should I repeat? Can you please let me know what part should I repeat? I will repeat that. Okay, so I'll continue. If there is anything that I need to repeat, please let me know. Okay. Do you want me to repeat from the start? Okay. So what I have done first is that I have created a ball and a paddle using these two functions. Okay. So that is fill circle and fill rectangle. Paddle is rectangular, and this in circle, the inputs that I'm giving for this function is x1, y1, 2, and white, where x1 and y1 represent the position coordinates of the ball, 2 is the radius of the ball, and white is the color. And fill rectangle may I have x and y, which are the top left corner coordinates of the rectangle. 20 is the length and 4 is the height of the paddle, and white will be the color. When I say display dot display, I mean that whatever changes that happen at every time during which the game is running, I want those changes to be updated. So display dot display will update the changes. Okay. And after this, I went to in create some variables. One for the position coordinates of the center of the ball represented by x1 and y1. And at the start of the game, the x position of the ball is 64 and y position of the ball is 32. Then I defined coordinates for the paddle, which are the basically the top left corner coordinates, which is 55 and 60. And then the speed, I'm keeping it as 1, comma 1, and the score initially is 0. Any doubts? I hope I'm clear with the part now, and I request all of you to please be along with me so that we can, complete the game together. Okay. So now what is the next step? Let's check. I have created all the variables. Next is the movement of paddle. Now there are push buttons, and I have to define how the paddle will move every time I click a push button. So let's do that. But before doing that, the most important thing, I have to define pins. Let's do it. So the other push button is connected to the 18th pin. Okay. And then I also have an LED which is connected to the 19th pin. And that will be declared as output. Okay. Now after this part, I will add one more thing that's going to be display dot clear display. Okay. Yeah. Yeah. So why clear display? Why this function? Because when the code starts to run, I want at the start of the game, I want the screen to be clear. With clear screen, I will start the game. Let's run this loop. Let me add a delay of 1000 is 1 second and show you how the ball is, all the rectangles are appearing. Okay, it shows some error. Shouldn't show, but let's see. Um, you see the problem right now. Okay, we'll just continue and we'll see. Okay. We'll just see, we'll carry on and we'll see if, we'll continue. At least I'll try to explain you the coding part. Okay. So we have declared now we will, you know, uh, see how the paddle will figure out the code for the movement of paddle. So let's see. Okay. Now I'll write code for movement of paddle. Now I will define two more integers, k1 and k2, which are going to read the values of the push button. Okay. So int k1 comma k2. So let's say k1 equals digital read of, let's say, this push button. This is connected to the 18th pin. So I'll say 18. Okay. Now, if k1 equal 1 and x plus 20 less than or equal to 127. What does this condition mean? That is, let the ball is moving. K1 is equal 1 means that the push button is pressed, and x plus 20 less than or equal to 127. X, as I told, is the top left position coordinates. And if that is plus 20, which is the overall length of the paddle, if that is less than or equal to 127, that is the paddle is within this screen range, then I will write x equals x plus 3.5. That is, I am saying that the x coordinate should be increased by 3.5, which means the paddle will move to the right by a distance 3.5. And for clarity, I will write serial dot print line right. which means in the serial monitor, I will see right when I press this push button. Okay. Now for the second push button, which will make sure that the paddle moves to the left. It is connected to the pin 16th. So very similar, but since it has to move to the left, I will be subtracting 3.5. That's the difference. So this will be K2. That will take the reading from the 16th pin. Okay. And here if K2 is high and X is greater than or equal to 1, that is, it is greater, it is in the screen. Then X becomes X minus 3.5 and serial print line will be, it will print left. Okay. So with this code ensures this code checks for the movement of the paddle. So with this, we are done with how the paddle will be moving either to the left or right. Okay. Let me try running this code. Oh, and I forgot to add semicolons. Good. So to add a semicolon, let me do that. I think apart from this, I don't see any problem. If you guys know anything, please let me know. Okay. So now we are done with the code for the movement of paddle. What is the next part? Next part will be writing an if condition for the scoring case. That is when the ball hits the paddle, which we will cover a little while later. The next one is boundary conditions. What are boundary conditions? So boundary conditions is basically we are playing a ping pong ball game where the ball is obviously hitting the edges. It's hitting these boundaries. And when it hits the boundaries, the direction of the speed changes. So we will be noting down those changes. Okay. So let me start with that boundary part. Okay. Now these are boundary conditions. Okay. So first, let me write for uh, the edges, the left and the right edges. Okay. So let me say if 2 less than x1 less than 125. So what does this represent, this condition? This represents the boundary which are located at the left and the left and the right edges. Okay. This basically represents the left and right edges, and 0 less than y1. Okay. So what happens when the ball hits the vertical edges? What happens? The direction in the speed in the x direction or Okay, let me write this. So this is basically sorry, I made a mistake. This represents the case where the ball is moving in the screen. So in this case, it will be x speed equals x speed and y speed equals y speed. Okay. Now the next case is when it is hitting the left and right edges, which is given by if x1 equal 125 or x1 equal 2. What is this case? What is x1 equal 125? The rightmost edge. What is x1 equal to? The leftmost edge. Okay. So in that case, the direction, the x direction, the direction changes, but the y direction remains same. So I will write it as x speed becomes minus x speed and y speed becomes, it remains, the direction remains the same. Okay. This is for the left and the right edges. Fine. Next one is when the ball hits the uppermost edge. So if z1 equal 2, that is, this is 2 is going to be the uppermost edge. This is going to be y1 equal 2. What will happen? The speed in the y direction, the direction of the speed y speed changes, but the x speed remains same. So I'll write it as y speed equals minus y speed and then x speed equals x speed. Okay. Yeah. Now we will come to the scoring part. That is when the ball hits the paddle. So basically we have covered the left, right and the top edges of the edge conditions. Now what happens when the ball hits the paddle? Let me add a comment here that says this is for the top edge. Okay. Now what happens when the ball hits the paddle? There is an increment of score. Okay. So let me write it as, okay, I'll write it as if x less than equal to x1. So x1 is the x coordinate of the center of the ball and the x is the top left corner position coordinate. X less than or equal to x1 and x1 less than or equal to x plus 20. So what does this represent? X1, that is the position coordinate of the center of the ball, is between it is it is lying in the paddle area, right? So and z y1 plus 2 equal 59. So this represents the case where the ball has hit the paddle, where it has touched the paddle. Okay, so in that case, what do we do? First, of course, the most important thing, the score increases. So I'll and of course the speed, the direction changes. So I write y speed equals minus y speed. Okay. And x speed equals x speed and score gets incremented by 1. So score score plus 1. Okay. Um, and since I've added an LED light, I would want it to blink for say a short time when the ball hits the paddle. So I'll write digital right 18 comma high. It will be delayed for 20 milliseconds, and then digital write 18 comma low. Okay. So this is for the case when ball hits the paddle. Uh, Now let me try running it, but I think it might show an error again. Okay, I made a mistake here. The LED pin is connected to 19th, so this should be 19. Let me remove this. And one more thing, I forgot about that. How do we relate the position of x1 and x? So the speed keeps getting added to the coordinates of the ball. So I will write x1 equals x1 plus x speed, and y1 equals y1 plus y speed. Okay. Now let's see. Okay, showing an error again. There's something wrong with the declaration of variables part. Let me check that.
Deepti,
Yeah.
in line 9, you haven't given a semicolon after y1.
Oh, thanks.
Try running, no.
Yeah. Guys, for some reason it's showing the error. If you get the code, please help me. Anybody has got any? So you're suggesting I should use A and B instead of X and Y when? Okay. So let's try doing that. Okay, I'm replacing X1 with A and Y1 with B. Hmm? Akshay, what I? Hmm.
Deepti, check in the second if loop. Two A's are there.
Which one? Which line?
Yeah, it's fine,
Oh,
fine,
this.
fine. So
Hmm. Okay, let's try running. Yeah, it's working now. Oh, uh, there is a problem which I. Okay. So why was the problem? Okay. Thank you to the person who told me to replace X1 Y1 with A and B. Thank you so much. Uh, After display, I have to write here display dot clear display. I think now it should work fine. Let me run again. Yes, it's working fine. Okay, we can try again. replay. And this is for the right push button. So you can see the paddle moving and the ball bouncing back. Thank you so much, guys, for helping me out. Thank you very much. So I hope the code that I've written so far is clear now, right? Okay. Now, okay, so in this game, I want this code to be visible on the screen. So I will write a code that will, so this is for the score, the current score display on the screen. Okay, so will be like, first again, as Akshaya taught us, display dot set text size. Let me make it as 1. I will choose the smallest size so that it won't interfere with the game. And go for display dot set text color. Let me set it as white. This is something that we all did in the simulation just now. Display dot set cursor at I want it to be displayed at the top right corner. So I'll write the coordinates as 115, 1. And what should it print? It should print display dot print. And that is score. Okay. Let me run the code. Yes, it's working now. So you can see the score appearing here on the top right corner. So the score is getting incremented by 1 every time the ball hits the paddle. And observe what is happening at the boundary. When the ball hits the boundary, these conditions, the if statements that I wrote, are being executed. Oh, the game is over. So what should ideally happen when the game is over? It should display the score, right? So I have to, I wrote, when I came to boundary conditions, I wrote 1 for the left and right edges, 1 for the top edge. Now and for the bottom edge, remember that there will be 2 cases. The one is when the ball hits the paddle, which I have written here, this part, that is when ball hits the paddle. But when ball misses the paddle, the game is over, and that needs to be that code I have to cover. Okay, so this is when ball hits the paddle. Okay, now let me write code for what happens when the ball misses the paddle. Okay, if y1, that is the position coordinates of the ball, that is greater or than or equal to 61. What is this condition? Now, as I mentioned earlier, the y coordinate of the paddle is going to be constant, and that is equal to 60, right? Where did I mention that? Yeah, this one. So the y coordinate of the ball is going to be 60, and it's going to be y coordinate of the rectangle will always be 60. So the moment the ball crosses this y coordinate, then that means the player has missed hitting holding the paddle in place, and the game is over. So I will write condition for game being over. Now first thing, I want the score, the LED to blink for a longer time to indicate that the game is over. So I'll write digital, right, 19 comma high, and this time I'll give it a delay of 1000 milliseconds, that is 1 second, because the game is over and it has to be on for a longer time. Then it will switch off. So digital, right, 19 comma low. Okay. So what is okay? So when the game is over, the display, first thing, it should be clear, and then there will be a text that will score equals, and it will display the score. So I'll write display dot clear display. Then again, I'm gonna set the text size and stuff, which I can easily get here. Okay. So here, the text size, here I'm gonna just make it a little big because it's the final statement. Text color is white. Position the cursor coordinates, I'm gonna set it at 25, 25. And what is it going to print? It's going to print score. Like it's going to say print score. So then it will print the number. Okay, let's try playing this game. Oh, it's supposed to be B. Made a mistake. Sorry. This will be the game over condition. Yeah. Now the game has begun. And you can see every time the ball hits the paddle, the LED blinks, but for a very short time. So what happens when the game is over? That is when the paddle misses out on the ball. Game is over. It's displaying score 1. Okay. Uh, Now the problem here is that I don't want to start compiling it again and again every time I'm end the game. So what is actually happening here is that when the game is ended, when the game gets over, I have to again click on start the simulation to start the game. So to prevent that, I will add some text here, that is print score, then display dot display. Okay, so I'm now going to again say A equals 64 and B equals 32. So what am I doing is that when the game is over, I am again giving the initial coordinates, that is A was 64 and B was 32 at the start of the game. So I'm going to restart this game without having to press the start the simulation button. Okay, so I will write score equals 0, then x equals 55 again, and y equals 60. So this idea was given by Akshya. So thanks to her, we are having a game which can be played continuously. Let's try compiling it. Again error. Oh, I made it O. Sorry. Should be 0. And also add a clear display, otherwise the score will get printed here. Okay, let's start. So you can see here the light is also blinking and the game is going good. Okay, let's see what happens when the game gets over. It displays the score and then the game again starts. Okay, so with this, we have completed making the game. Any doubts, please feel free to post it in the Q&A section. Let me check. Okay, so what changes do we have to do for making it quite fast? Well, you have to actually, you can easily increase the speed, but the problem here is that there are a few if conditions that we are using for boundary, right? So we have to make sure that the ball can hit, like when I say for the winning condition, this is the case, that is B has to be greater than or equal to 61. Now, when you increase the speed, the problem is that it might not ever encounter this pixel. So you have to take care of that when you are increasing the speed. That needs to be done. Okay. See. Explain void loop once again. I'll do that. Yeah. Thank you to all the people who recommended me to use A and B instead of X1, Y1. Okay, I'll explain the void loop part again. Okay. So first thing, yeah. Now this part will help us print the score on the top right corner of the screen. That is display set text size. I'm setting the text size to 1, setting the text color to white, setting the cursor at 105, 1, 115, 1, which is at the top right corner, and it will print score. what is score? Score is a variable that I've already declared to be 0, initialized it to 0. Okay. Now we go for the code for the movement of paddle. Now there are two push buttons that I'm using. One is to move the paddle to the right, one is to move it to the left. The one that is used to move to the left is attached to the 16th pin, and the one that is used to move it to the right is attached to the 18th pin. Okay, so I am again declaring two variables, k1 and k2, which are going to read the input of these two push buttons. So this is attached to the 16 pin, and this will be used to move left and this will be used to move right. So K1 is going to be the variable that will read the 18th pin. So when I say if K1 equal 1, that means that the push button is being pressed. That means this is digital, it is high, and x plus 20 less than or equal to 127. That means the paddle is it is inside this. It will never. We are making sure that the paddle will never cross 127. It is below below x equals 127, which is going to be the rightmost edge. When I press this push button, what happens to the x coordinate of the paddle? It increases by 3.5. That means it will move to the right by 3.5. And in the serial monitor, I will get right. Okay. Same thing for the left, for the other push button, but the only difference here is that number one, the pin is changed, it is 16, and we are using the variable k2. X greater than or equal to 1 means the paddle is away from the left edge of the screen, and when I press this push button, the x coordinate is decreased by 3.5, which means the paddle will move to the left by a distance of 3.5 with every click. Okay. Next, we come to the boundary conditions. So these are the boundary conditions. That is what happens when, we are having a ball which is moving. So when it hits the boundary, it has to get reflected. It has to get bounced back. So we are basically defining conditions for the ball to get bounced back. The first case is quite simple. It's the case where the ball is within the boundary range. So in that case, the x speed will remain as it is and y speed will remain as it is, no change. The second if statement is where we are telling what happens to the speed of the ball when the ball hits either the left edge or the right edge. So the left edge is defined by a equal to. That is when a is the center position of the ball. So what happens when the ball hits the left edge, and that is a equal to, and what happens when it hits the right edge? So when it hits the right edge, its center coordinate becomes 125. So when it hits a vertical edge, what happens is that the direction, the speed direction along x changes and along y remains same. So I will write it as x speed equals minus x speed and y speed equals y speed. The other condition is when the ball hits either the upper edge or the lower edge. For the upper edge or the top edge, the y coordinate of the center of the ball will be p equal to. And in that case, the y speed direction changes, but the x speed direction remains same. So I have y speed equals minus y speed and x speed equals x speed. The last if statement, that is the case when the ball hits the paddle. When the ball hits the paddle, it's very similar to what happened what happened to the direction of the speed when ball hit the top edge, but there is another thing that we need to add, and that is score. So when the ball hits the paddle, the score gets incremented by 1 and the LED blinks for 20 milliseconds to convey that that the score has been increased. The next part that I've written here, this is basically a equals a plus x speed. That is how we are defining the movement of the ball. That is the speed in x direction gets added to the x coordinate of the ball, and the speed in y direction gets added to the y coordinate of the ball. So these two statements convey that. And the next two statements is the basic one, that is to create the ball and the rectangle. And display will bring the changes, and display.clear display will prevent like every time the ball moves from one position to the another, it makes sure display.clear display will make sure that the previous position of the ball is cleared. Okay. Next is the game over condition. Game over condition is where the y coordinate of the ball crosses the y coordinate of the rectangle. Crosses as in it is higher than the y coordinate of the rectangle. So in that case, it's a game over condition. So I want the LED to blink for a longer time. So it will blink for 1 second. Next is display dot clear display. That is, when the game is over, I want the screen to be cleared of the paddle and the ball. So both of them would not appear on the screen. Next, I'm using the same pattern that I used in the start to make sure that the score appeared on the top right. But this time it will appear at the center, telling me the final score. Okay. So here the text size, I'm setting it as 2. I want it to be of larger size, and color is white. Cursor is at 25,25, and it will print score. Next, display.display, as I mentioned, it is going to bring the changes into effect. So this score will be displayed for 2 seconds. So delay 2 seconds means score will be displayed for 2 seconds. And then the screen gets cleared, and the whatever I started with, that is the initial values of, say, the center of the ball, the position of the paddle, everything, I'm going to start with the same. And score will become 0. And when this happens, the game again continues. So it's like the score will be displayed for 2 seconds and the game will again continue. Any doubts? Please ask. Please post it in the Q&A section. Let me check.
Guys, just telling you, the attendance drive link has been posted. Not drive, I mean attendance has been posted. You guys can fill it before 12:30. We'll be keeping it open till then.
So whenever the ball or paddle moves, its previous position is also displayed. The object moves as a trail. What should I do? I think you can add a clear display.clear display. That is like this. After all this thing, add a display.clear display. That will not leave a trail. Okay. Okay, next question. So answer. Why do I get display not connected? What do you mean display not connected? Is it like the SSD 1306 is not getting connected? Yes, we will be sharing the code, and we can also add a statement where it's code. Oh, yes, that's a very good idea. That's actually a very good idea. But the problem is that we have to, apart from just adding an if statement, there are certain things that we need to take care of. Okay. As I said, when we define the boundary conditions, we should make sure that the ball is reaching that boundary condition. Okay. Shouldn't A be greater than or equal to 3.5 in the second if condition? Shouldn't A be greater than or equal to 3? No. We need not have that condition here. Just look at the boundary. If you understand the boundary conditions, you don't have to worry about this value 3.5 or 3. You can just change it anyhow you want. Okay. The LED isn't glowing for me. Okay. Please check the many a times. I mean, please check if you have added pin mode. Uh, this statement in void setup. X and Y speed क्या है? X and Y speed, they are the speed of the ball. So the speed of the ball can be expressed as x cap plus y cap. Okay. Or x cap plus y speed y cap. After the game ends, the score display isn't displaying for 2 seconds as per code. I think it is displaying. I'll show you. I'll run it once and I'll show you. Okay. Where is the attendance link will be posted? What can we write if we want the ball location to start from random locations, mainly between top to middle? I am not very sure of that, but I will look into it and I'll answer you. Okay. Ma'am, we can also add a if statement where if score reaches a certain value, we can increase the speed of. Yes, again, as I said, you need to make, when you add an if statement, you have to make sure that the ball reaches that. So the boundary conditions are defined with respect to a certain, say, x and y value. So you have to make sure that when you increase the speed, the ball will reach that boundary condition, else it won't. Oh, you have added. Okay. Uh, Display is blinking. Okay. Once we will share the code after this class gets over. So I request you guys to go through the code and check where you might have made an error. In case if you still get errors, you can feel free to text us about it and we will help you out. And regarding the if statement, let me add and show you what happens if I add an if statement. Okay. 1 second. Let me say if score is greater than or equal to 2, then increase the speed of the ball. So x speed equals to and y speed equals to. So let me show you what happens. The speed is 1 now, 1 comma 1. Okay, so you can see that it's not bouncing back, right? Because of this condition, because of this case. So we have to, or perhaps even this case, the scoring case, it might be so that because the speed is 2 comma 2, b plus 2 equal 59 never happens. So we have to write some more cases for that. Okay. I hope I'm clear with that. But we can always figure out a way to increase the speed. Yeah. How does the ball initiate motion? Okay, so I have defined the position coordinates of the ball and I have defined some the x direction of speed and y direction of speed. So when I say void loop, what is actually happening is that every time the loop gets repeated, the x speed gets added to the x coordinate of the ball, and the y speed gets added to the y coordinate of the ball. So the every time it's like every time the loop repeats, the ball moves, and that's how there is motion in ball. Okay, hope I'm clear with that. Next. Okay, sure, thank you. Yeah. I hope all the doubts are clear. If there are any doubts, please ask. And the attendance link is posted in the chat. Any doubts? I'll be here for a few minutes. Please feel free to ask any doubts. And we get, yes, you will get the walkway link. And how to save the project? Just click on um, save option. You'll be able to save a project. Can we submit the second task? Yes. The ball is not as fast moving your code despite being the same. I'm sorry, I'm not getting your question. Could you please repeat? The ball is set, the speed of the ball is set at 1, 1, so it will move at that speed. Uh, Bhavesh, I'm sorry, I don't get your question. And regarding how to save the project, you will see a save option that is at the top left corner of the Walkway project. You can save it and you can also share the link.
Guys, if you have any doubts, stay. Otherwise, if you're done and you've filled the attendance, I think you guys can leave.
In my code, the ball is moving slowly compared to your code, which seems to be faster and much smoother. I am not sure of this. Maybe, oh, or maybe is it again somebody mentioned maybe because of the time screen lag? Maybe because of that. I'm not sure. After game over, the game automatically starts after 2 seconds. But if I want the game to restart only when any of the push button is pressed, what can we write? So you want the game to restart only when any of the push button is pressed. Okay, so the condition, the way we have created the game here is that when the game gets over, only you can restart the game. In case if you're in the middle of the game and you want to restart, perhaps you can add another push button and say if that push button is pressed, then okay, set. So when that push button is pressed, set the values again back to the initial values. Score equals 0, then A and B equals to the values that we set initially, all that. Hope I'm clear with that, Yuvraj. removing the LED will make any change. No, it won't make any change to the game because this game, you can, it will just you can continue to play in that. Except that you will not have an LED that will be blinking every time the ball hits the paddle or something. Maybe it can be device limitations.
Someone has asked where the attendance link is. It was actually posted in the Q&A section. You guys will have to scroll down a bit. Or it's also there in the chats. And the form is open till 12:40 max. And after that, we're closing it. So you guys better do it fast.
After game over, you want to restart with a push button. Okay, then maybe you have to modify the code such that. Okay, I'll share my screen.
Now you'll have to write that in that if condition, right? You'll have to add if either K1 or K2 is high. You can use that condition and it will work.
Sorry, I left by mistake. Let me share the screen.
Deepthi, I think in that if loop, right? If that paddle hits, if the ball hits the bottom part, there you can add if K1 or K2, either of them is high, then only then it will go to the next part. Otherwise, it will just stop. Like you'll have to write an if and else.
But the thing is, if K1, okay, so you're saying if I click both the push buttons together, then it should
No,
restart.
either. Like if K1 is double equals 1, if K1 and K2, either of them is 1. So if K1 double equal to 1 or K2 double equal to that, you'll have to
Yeah.
use.
We can do that. So I'm clear with that, Yuvraj. Well, next session, no, it will be on digital design. Next two sessions will be covering the digital design. Okay. So any other doubts, guys? Please post. There are 5 more sessions. This was our first module, microcontroller arena. The second module will be digital design, where there are 2 sessions, and the third module is signal processing, which have 3 sessions. Okay. And again, the timings, the schedule is going to be the same: Monday, Wednesday, Friday, 10:30 to 12:30. Yes,
The
code will
code
be
will be
sent. Thank you, Bhavish. Thank you so much. Guys, any other doubts? Please ask. Sure. Thank you so much. Thank you so much. Thank you guys for, I really encourage you to ask more doubts. This will help me to learn as well. Thank you very much. Thank you. Hope you guys also had fun and hope you guys will also explore the field of electronics.
Yeah, and
You
today
can
you
also
guys have
try
such a
making
very
the
basic game. You can make modifications, like some people are suggesting, right? You can increase the
yeah,
speed, like at the
yes,
beginning, or with
yeah,
each
maybe
time it lands on the paddle, you can increase the speed, double the speed, change directions, or start from random points at each interval by using maybe some random libraries. Something like that is also possible.
maybe make a ping pong ball game which has like
Two
changing colors.
players.
So every time there is displayed or display, you can see a ball of different color. It's
Yeah.
gonna be
Or
fun.
you guys can do, two-player kind of game. Anything. It's all open, but this is just the basic which we have taught you guys. Are there any more doubts, guys? If there are no more doubts, then we'll be ending the session in another 2-3 minutes. Yeah, there will be an assignment. We'll be sharing it to you by today evening. Assignment 2. I think you can post it on the group, like whatever doubts you have, any of the coordinators or even your friends will help you with that. Or you can DM any one of the admins, I guess. Any other doubts, guys? Shoot it, or we'll be ending the session
Yeah,
soon.
regarding the doubt in your assignment too, you can DM us and we will help you out.
Deepti, shall we end the session now? Deepti.
Yeah, we can end. I think no more doubts.
Yeah. Even if you guys have any doubts, post it on the group or DM any one of the admins. We'll reply to it as soon as we can. So yeah, then bye guys. See you guys in the subsequent sessions. Thank you.
Yes, I hope you enjoyed the microcontroller arena and had
Yeah.
fun with us. Do keep exploring, keep learning. Happy learning, guys. Bye.
Bye guys.